Howdy. So let's go ahead and get into some basic concepts of operator overloading. So an overloaded operator is going to be defined as a function, and it's going to have, as any other function, a name, which is going to be the keyword operator, followed by the operator being defined, a return type, a parameter list, and then a body, which will define what it means for that operator to be overloaded. So let's say we have two color objects, C1, C2. What if we were to write something like C1, C2, so a test of equality? The compiler cannot infer essentially what this means, so we're going to go ahead and have to define what it means for two objects of type color to be considered equal. So to do that, we'd go ahead and define an overloaded operator for this. Bool, because it's going to evaluate true if the test of equivalence passes, false otherwise. The operator, or the name of the function, is going to be operator equals. And then we're going to pass essentially by constant reference two arguments of type color. So const color, go ahead and call this LHS for left-hand side, const color RHS for the right-hand side. And I'll let you all define this however you want, but it is for a user-defined type. So we determine what it means for two objects of this type to indeed be equivalent. So you're probably going, that function looks nothing like how I'm actually using it in practice. So one thing to note is when we see something like this, it's going to evaluate to this. And the key thing to point out here is the first operand is going to be used to initialize the first. Let me do that in a different color. The first operand is going to be used to initialize the first parameter in the parameter list, hence why I called it LHS. The second parameter second operand will be used to initialize the second parameter. In this case, that's why I named it RHS, just so it's clear which operands the two parameters are going to be referring to. So we'll get into this a bit more in a bit, and I believe I have an example on definitely a symmetrical operator that's being overloaded, and we'll get into a bit more of a discussion then. But right now, let's just continue going through this. So as one might suspect, an overloaded operator is going to have the same number of parameters as the operator has operands. That's going to be a single parameter for a unary operator, like defining what it means to write a negative color. And then we'll have two parameters for a binary operator. In this case, and as shown on the previous slide, the left-hand argument would be used to initialize the first parameter, the right-hand argument for the second. Now, naturally, the next question that might arise from this discussion is, well, what operators can I overload? Am I able to create new ones? So the answer to that is we can only overload existing operators, and we cannot invent new operator symbols. What we will see here is that four symbols kind of have double meaning: asterisk, ampersand, and plus and minus serve as both unary and binary operators. Within your applications, you can go ahead and define what it means for either or both of these operators to be overloaded. It's going to be the number of parameters that's going to determine whether the unary or binary operator is being defined, so this will be inferred. An overloaded operator will have the same precedence and associativity as that of a built-in operator. Therefore, regardless of the operand types, the expression x is assigned the result of y plus z is going to be evaluated just as such. So the last thing we're going to go and point out is something that might not be as intuitive as we'd like to think the first time around, but there's going to be a slight difference in terms of the number of parameters when the function is overloaded as a member function versus when it is overloaded as a non-member function. If we overload an operator as a member function, we're going to see here that when we invoke it, like let's say we're writing, and I'm not even going to bother defining what this means just yet, but if we write something like C1 plus equals 1, who knows what that means to add 1 to a color object? Let's assume we're actually defining this as a member function. What this is going to evaluate to is C1 dot operator plus equals followed by 1. We can see here, and as we will see in the actual declaration for operators that are defined as a member function, we have one less, despite being a binary operator, we have one less argument and one less parameter that's being passed into it. Why? Later on, we'll see that when we use the dot notation, this object, or at least its address, actually is passed to the function as well. And where it is stored is essentially within a pointer called this. So we have access within any sort of member function to the object that invoked it, even though it is not passed as a parameter to those functions explicitly. It is indeed passed implicitly. So just understand what's drawn here for now, and we'll go from there. Now, if the overloaded operator is defined as a non-member helper function, it's going to have both those parameters. For instance, if we go ahead and consider the test of equality case, which we'll see here is going to always be defined as a non-member, C1 is equivalent to C2 gets mapped to operator will equal with both of the arguments explicitly passed to this overloaded operator, meaning it's a binary operator, and indeed we see two parameters and thus two arguments for this non-member helper function. Whenever we're going ahead and defining, say, an overloaded operator as a non-helper function, it's going to be critical that at least one of its parameters must be a user-defined type. This implies essentially that we cannot change the meaning of an operator when applied to operands of the built-in types.